Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. In this video, I would like to continue our discussion in second order differential equations. Previously, we already discussed how to solve for linear homogeneous equations. So, in this video, I would like to discuss how to solve for linear non-homogeneous equation. The linear second order non-homogeneous equation is written as equation number 1. A d square y dx square plus b dy dx plus cy equal to fx, where a, b, and c are constant, while our fx must be in terms of x. So the general solution of equation 1 has the form of yx equal to yh plus yp. So YH represent the general solution of the homogeneous of equation 1 and YP denote the particular integral of fx. Or we can say YH is a general solution for homogeneous equation. That means AY double prime plus BY prime plus CY equal to 0. And we already discussed how to find the general solution for homogeneous equation in the previous video. While YP is the particular solution, a particular integral of function fx. In this section, we are going to determine the particular integrals yp for linear non-homogeneous equation. So this is our second order linear non-homogeneous equation where our fx is not equal to 0. So the method that we are going to use is undetermined coefficients, where this method is a simple procedure for determining the particular integral when our fx has a special type of function. Here is the theorem for method of undetermined coefficient. We know our general equation ay double prime plus by prime plus cy is equal to fx, where our fx we can write in this form: c x to the power of n exponent rx, combination between constant, polynomial, and exponent, where our n is a non-negative integer. So our yp will have this form: x to the power of s multiplied with an x to the power of n until a naught multiplied with exponent rx, where s equal to 0 if r is not a root of our characteristic equation, and s will be equal to 1 if r is a simple root, or we can see it as one root of our characteristic equation, or s equal to 2 if r is a double root of our characteristic equation. Or the theorem can be simplified as table below based on the specific function. The first function, fx is equal to constant. So this is our fx, c. So our yp will become a multiplied with x to the power of s. Second function, polynomial. So this is our fx, cn x to the power of n until c0. Then our yp will become an x to the power of n plus until a0 multiplied with x to the power of s. And the next type of function is an exponential function. So this is our fx, c exponent lambda x. So from here, our yp will become a exponent lambda x multiplied with ss. So these are the steps how to solve for linear non-homogeneous differential equation. So first step, okay, you need to find our YH, where YH comes from linear homogeneous equation. That means your equation must be y double prime plus by prime plus cy equal to 0. Then Then the second step, okay, we need to find our YP and our YP based on our fx. After that, you need to differentiate YP twice. Then substitute YP prime and YP double prime into our original problem. That means AY double prime plus BY prime plus CY equal to fx. The next step, we are going to find the value of the constant by comparing the left side and the right hand side. And lastly, we just need to combine y equal to YH plus YP. For better understanding, so let's try to solve a problem. Example 1. Find the solution of the differential equation y double prime minus 5y prime plus 6y equal to 24. So this is our fx, where our fx is a constant. So our general solution, y is equal to YH plus YP. So let's start with YH first. We know YH based on homogeneous. That means our equation must be equal to 0. So how to solve for homogeneous equation? Firstly, we change into our characteristic equation. So we will have lambda square minus 5 lambda plus 6 equal to 0. Our characteristic equation in form of quadratic, then we need to factorize. From here, we have our lambda 1 is equal to 2 and lambda 2 is equal to 3. Since we have different roots, so our general solution for different root is a exponent 2x plus b exponent 3x. Now, let's start to determine our YP. YP based on our fx. And our fx is a constant. Based on the previous table, if our fx is a constant, so our YP, we will have another constant multiplied with x to the power of s. Okay, so from here, our fx is equal to 24. So our YP is equal to another constant c multiplied with xs. Okay, how to find the value for s here? Let's compare our YP with our YH. Since C, we don't have any same element with YH, so S equal to 0. So we have YP is equal to C only. So now we can differentiate our YP twice. Differentiate for the first time, we will have 0. Differentiate for the second time, we will have 0 also. The next step, we just need to substitute these 3 equations into our equation here. So substitute, we will have y double prime 0, y prime also 0, y is equal to c, so c equal to 24. So from here, c is equal to 24 over 6, we will have 4. So YP is equal to 4. Lastly, just combine YH plus YP, y equal to YH plus YP. So our general solution for non-homogeneous equation, we will have A exponent 2x plus B exponent 3x plus 4. The next example, let's solve this equation y double prime plus 2y prime equal to x. So first step, we are going to find our YH. YH comes from our homogeneous equation. So we will have y double prime plus 2y prime equal to 0. Change into our characteristic equation, we will have lambda square plus 2 lambda equal to 0. Factorize, we will have lambda 1 is equal to 0 and lambda 2 is equal to minus 2. Here we have two different roots. So our general solution for different roots, YH is equal to A exponent 0x plus B exponent minus 2x. Since exponent 0 is equal to 0, equal to 1, so we have A plus B exponent minus 2x. Now, YP. YP based on our fx is equal to x. So this is a polynomial, x to the power of 1. So based on our table, if our fx is a polynomial, so our yp is equal to, we have an x to the power of n until a0 and multiply with x to the power of s. So here our fx is equal to x to the power of 1. So our yp is equal to cx to the power of 1 plus dx to the power of 0 multiply with x to the power of s. Or I can write as yp is equal to cx plus dxs. So how to find the value for s here? We compare our yp with our yh. We have same element or not? Yes, we have same element d and also a. Since we have same element, then we need to our s become equal to 1. So our new yp is equal to cx plus dx to the power of 1. Or we expand, we will have yp is equal to cx squared plus dx. Okay, now we can differentiate our yp twice. So differentiate for the first time, you will have 2cx plus d. Differentiate for the second time, you will have 2c. Then we substitute yp prime and yp double prime into our original problem. So we will have y double prime is equal to 2c plus 2. Y prime is equal to 2cx plus d equal to x. Now we are going to find the value c and d. Okay, so we just need to compare between left side and the right hand side. Okay, so we expand first. 2c plus 4cx plus 2d is equal to x. So when x is equal x to the power of 1, so we have 4c equal to 1. So c is equal to 1 over 4. When x to the power of 0, we have 2c plus 2d equal to 0. We already have the value for c here. Then we just need to find the value for d. We just rearrange d is equal to minus 1 over 4. So from here, our yp is equal to cx squared. That means 1 over 4x squared plus dx minus 1 over 4x. Lastly, our general solution, we just need to combine yh plus yp. So we will have a plus b exponent minus 2x and plus yp 1 over 4x squared minus 1 over 4x.